Thanks, everyone. Very happy to be here, and thank you for showing up so early for this talk. We're going to try and get through some live coding today and a quick overview of how Aztec Connect works. The agenda today, go through the ETH Denver bounties, an overview of Aztec Connect, discuss some of the ideas for the hackathon that you can work on, a bit more detail on how the actual layer 1, layer 2 interface works, and then we're going to attempt to do some live coding and code up a Uniswap bridge to interact with layer 1 Uniswap from inside Aztec using Aztec Connect. I want to make it interactive, so if you guys want to ask questions, just stop me and I'll do my best to kind of answer them so we can learn something today. So for those of you who don't know, Aztec is a private roll-up on Ethereum. We bring 10 times gas savings and privacy to Ethereum. We launched about a year ago with private payments, and we're about to launch Aztec Connect, which is our interface to all of Layer 1 DeFi. We're thrilled to be sponsoring the hackathon. We have 2 tracks for kind of our bounties. Both of them are available for in real life participants and virtual attendees. On the left-hand side, we've got privacy-enabled dApps, so using our SDK to build kind of new interfaces, things like ZK Money, DAO payments, private kind of batch payments to contributors. And on the right-hand side, building Aztec Connect bridge contracts, so using the interface we're going to discuss today to interact with any L1 smart contract from inside Aztec. So let's go into a bit more detail about what Aztec Connect is. It's a private bridge to Ethereum, and it operates as a layer 2 sitting just below Ethereum. We're a bit different to some of the other L2s because we're focused on users moving their funds to Aztec, but the protocols stay on L1. We interact with them through a process called DeFi pooling, giving privacy and gas savings to users. So some of the highlights, we get about 10 to 100 times gas savings depending on which interaction you're doing, compared to an L1 standard Ethereum DeFi transaction. It depends on the complexity of the actual smart contracts, but on average we're seeing about 10 to 100 times gas savings. The main benefit the protocols enjoy is that we use layer 1 liquidity. So we're not moving protocols to L2. We're moving the users and we're interacting with the protocols on L1 directly. This means you can call kind of the $50 billion of liquidity on Uniswap directly from inside Aztec. And there's great kind of interoperability between protocols that use kind of multiple DeFi protocols. So for example, if your DeFi protocol uses Curve and Balancer to do swaps, like Element, you don't need to move all those protocols to L2. You can just interact with L1 directly. In terms of some of the kind of user stats, we're targeting around 8,000 gas for private transactions, plus a share of the L1 DeFi transaction cost. If you have 100 users doing a Uniswap transaction, kind of socialize that gas cost, 140,000 gas across 100 users. So you get kind of end-to-end Uniswap transactions for about 12,000 gas, which is pretty great. The rollup can support around 1,000 transactions per block, and we can interact with up to 32 different smart contracts per rollup. At the moment, we're targeting rollups every 10 minutes. So for ETH Denver, there's a few things that we've kind of seen through our Discord and people have been building or asking us to build. I think the most exciting ones are kind of private governance and private kind of voting. If protocol uses like on-chain governance, you can use Aztec Connect to vote privately and with 10 to 30 times gas savings. How this actually works is the Aztec rollup votes on behalf of all the users who it has tokens for. And that's something we're really keen to see bridges built for. Maybe a compound Governor Bravo integration and a front end that kind of manages proposals and lets people vote using Aztec. And on the left-hand side, You can also use Aztec Connect to purchase NFTs privately. So users supply ETH to a bridge contract on Aztec, and you can purchase NFTs on OpenSea. And it just looks on chain like the rollup has bought an NFT, and you don't know which user has bought it, which is kind of a cool problem when people are kind of doxing their degen trading accounts, purchasing NFTs and linking the two together. Also, we're happy to kind of hack on bridge contracts that are just to popular DeFi protocols. Through our grants program, we have about 20 bridges in progress, but there's a lot of protocols that aren't being built right now. So if you want to build a connector to Aztec, just come and see us at the booth and chat to us, and we can figure out the best way to integrate it. Okay, so in terms of the interface and how Aztec Connect works, all the interfaces are written in Solidity. It's just a layer 1 smart contract that maps a DeFi protocol to a function interface that the rollup contract can understand. And we model DeFi or any L1 smart contract as an asynchronous token swap, where you can pass in 2 input assets and receive back 2 output assets. And there's 2 kind of like models for the swap. One happens atomically, so in a rollup block, you could call out to Uniswap with ETH and expect back DAI in the same block. And there's also an asynchronous flow, which could be useful for limit orders, or kind of, we actually use it for the element bridge, where users kind of initiate a DeFi transaction in block 1, and in block 100 it settles, and users on Aztec get their funds back a certain amount of time later. So both of those are possible with the bridge. And we think that this interface really lets you interact with most of DeFi. So we're excited to see what everyone builds with it. As a quick example for Uniswap, actually before I dive into this, does anyone have any questions on the interface and what's possible with it? Yep. So the question was, how do we aggregate people together? Yeah, so maybe I can do this with the Uniswap example. Users create kind of trade intents or transactions using the Aztec SDK. And instead of kind of sending it to another user on Aztec, you end up sending it to a bridge address. So you can aggregate all transactions which are going to the same bridge address and have the same kind of function parameters. So for a Uniswap example, you can aggregate all ETH DAI swaps that have the same slippage. And it's up to kind of the front end and the SDK to kind of set that slippage to get the best batching. It's also up to the user to decide, do they want to kind of wait a certain amount of time to have higher gas savings, or do they want to pay just the full cost of L1 if they want to go instantly and kind of avoid batching. The rollup itself does the batching, and it just happens automatically. So if you send a transaction as a user, you kind of always have a chance of being batched, but it depends on how obscure your kind of DeFi interaction is. For common protocols, we'll kind of try and set the fees so that the batch is like sane compared to L1 traffic. So if we see a protocol has, I don't know, 500 daily deposits a day on L1, we may set the batch to be an hour and 20 transactions to get kind of reasonable gas savings for the user. Does that make sense? Cool. Anyone else? Okay, cool. So for Uniswap, the way this flow works, imagine I've got some shielded ETH on Aztec, and I decide I want to swap it on Uniswap. I send a private transaction using the Aztec SDK to an Aztec node. The input to that transaction is an amount of my shielded ETH, and I'm expecting back some ZK DAI. So the Aztec node then, based on the fees, decides to create a rollup proof, and it will aggregate transactions together, which have similar kind of trade intents or similar going to similar bridge contracts. And it creates a rollup proof for those transactions, kind of summing up the aggregate value, but keeping the user's identities hidden throughout the process. And then that rollup proof is sent to L1. It's effectively has inside it kind of instructions that allows the Aztec rollup contract on L1, which owns all of the user's funds, to make a trade with Uniswap directly through your bridge contract. So that trade is kind of on behalf of all the users who did that particular interaction. And because it's a zero-knowledge proof, we have kind of ironclad cryptography guarantees that when the trade happens, it's guaranteed that all the users, it's a correct record of events. There's no kind of optimistic roll-up delays here. Once the proof is valid on L1, we have the authority to actually transact on behalf of all those users. So then the roll-up sends a transaction out to Uniswap, receives back an amount of DAI, and this is sent back to the roll-up contract, and it's distributed pro rata to all the users on Aztec. So if you put in 1 ETH and I put in 9 ETH, I'd get 10% of the proceeds, and you'd get 90% of the proceeds. And that happens trustlessly by the Aztec nodes. They're incentivized to do that. And yeah, the most important part of this is that user identities are hidden throughout. So the privacy set for this transaction is anyone who's ever deposited ETH to the Aztec network. You could have been, at the moment, one of about 40,000 people who've deposited ETH to Aztec. And that's just growing every day. So the more DeFi interactions we have, the privacy set just grows for this. It's not a privacy set per batch. It's kind of a global privacy set for the whole system. Okay, so let's move on to some coding. There's a Aztec Connect Bridges repo, which is at this address. I'll give people some time to clone this down, and then we can go through the setup and start coding up Uniswap Bridge. Oh, sorry. It's fully collateralized in the rollup contract. So when you shield ETH, you deposit ETH to the Aztec rollup contract on L1, and you're given an encrypted UTX zone note that represents the amount you shielded. So it's not a different token. It's just you're given like an encrypted representation of that token that you can spend with Aztec proofs. But the rollup contract holds all the tokens for the duration of the time they're inside Aztec. Yeah, so the question was, would I get my tokens back in a one-to-one ratio? Yeah, you can always shield back or unshield your assets in a one-to-one ratio. The only time that there wouldn't be a one-to-one ratio is if there was a hack and the rollup lost some of its tokens. Any other questions? It's a good question. So the question was to maximize the anonymity set at the bridge layer. Is it useful to use a kind of standardized amount? So when you do a bridge interaction, the kind of privacy set, it's public how much is being transacted. So let's say I decided to kind of swap 1.696969 ETH on Uniswap. That's likely going to be identifying if at a later date I unshield kind of that amount of ETH. Oh, okay, we may not have time to do coding then. But yeah, so it is useful to kind of restrict the privacy set, restrict the amounts to increase the privacy set, but only very large amounts or kind of very high precision amounts can actually be identifying. And the identifiable like action is actually when you leave Aztec, not whilst you're inside Aztec. So if you kind of shielded funds to Aztec, did a load of DeFi interactions, but never left, you'd never be at kind of risk of kind of breaching your privacy. Cool. Has everyone managed to clone the repo? I may just kind of do a quick example of how to actually do this with Uniswap, but we've only got 5 minutes. So if people are interested, we can kind of come by the booth. We're at booth M2, which is 2 floors down, and we can go into a bit more detail. Cool. So this is a version of the Aztec Connect Bridges repo. We structured it so it uses Foundry, which is kind of Rust version of Solidity DevTools. We use it because when you're kind of interacting with lots of L1 protocols, it's much easier to fork from mainnet with this, and you get really good stack traces. So I've made a new folder here called Uniswap, and I've kind of set up a sample convert call with a few input assets. And I haven't implemented any of the code here yet, except the input asset swap when we have a token, and we also expect out a token. So you can see here, it's just like normal coding in Solidity. We can call the Uniswap interface to swap exact tokens for tokens. The rollup contract will provide the total input value, which is the value that all the users have sent, the aggregate total of all the users who supplied input asset A. And we can use that to kind of do a Uniswap transaction. And to kind of return funds back to the rollup, we just set the output value A of the convert function to the amount we returned back, and we approve those tokens for kind of being claimed by the rollup by just approving the ERC20 token transfer for the rollup. If I run some of the tests here, 1 second. This test is going to fail so far, but you'll be able to see kind of the call trace of what's happening, and kind of it may help people understand kind of the execution flow. So in our tests, we simulate a rollup being processed. Then the rollup contract calls out to our proxy contract, which will call out to your bridge, and then try and do the interaction. In our case, the interaction is failing because we're not returning the correct amount of tokens. But we can go through this later and fix it, because I think I'm out of time. Does anyone have any questions for now? I think we won't get to much more live coding. I would happily take some questions. Hey. Yeah, definitely. So we're working on a private smart contract language called Noir. The main difference between that and kind of some of the other languages is we'll have private state variables, private logic. So you'll use Noir not necessarily to recreate all DeFi protocols in the early days, but doing stuff like identity management, multi-sigs, and kind of anything where you actually need private logic and private state variables. And we're building it because I guess, Solidity doesn't have private primitives. So the focus of Noir is, just anything where privacy is like a core principle of your dApp. We have it live right now as a kind of an alpha language, but it's not actually in the rollup yet. So the next kind of 8 to 12 months are us focusing on putting Noir in the rollup, and we call that Aztec 3. So if you come back next year, I'll give a talk and explain how it works. Thanks for listening, everyone.